Hello, and welcome to the CodePilot's full beginner-friendly Python crash course. In just 1 hour, you'll learn the core basics of Python through 10 simple episodes. Hope you enjoy the show. Hello, CodePilots. Welcome to a brand new journey on CodePilot's channel, Python from Zero to Hero. I'm your guide, and we're about to embark on an epic adventure to learn Python from absolute scratch, all the way to pro-level mastery. Whether you've never coded before or you're looking to level up, this series is for you. We'll start with the basics, build real projects, and by the end, you'll be a Python rockstar. If you're ready to soar, hit that subscribe button, turn on the bell, and let's get coding together. So why Python? Let's break it down. Python's one of the most popular programming languages out there, perfect for beginners because it's easy to read and powerful enough for pros to build things like games, apps, or even AI. Companies like Google, Netflix, and NASA use Python, so you're in good company. In this series, we'll cover everything, starting with the basics like variables and loops, moving to cool stuff like data analysis and web apps, and finishing with real-world projects. This is going to be a long, awesome journey with tons of episodes to make sure you master Python. Let's start by getting Python set up on your computer. First, let's install Python. Open your browser and go to python.org. Yep, the official website. I'll show you the link on screen. Hover over Downloads and click the big yellow button that says Download Python 3.12 or whatever the latest version is. If you're on Windows, Mac, or Linux, it'll pick the right one for you. Once it's downloaded, run the installer. Here's the key step. Make sure you check the box that says Add Python to Path. This lets you use Python from anywhere on your computer. Click Install Now and wait for it to finish. To test it, open your terminal. I'll use Command Prompt on Windows, but it's the same idea on Mac or Linux, and type Python --version. If you see something like Python 3.12.0, you're good to go. If not, let me know in the comments, and I'll help you troubleshoot. Next, let's set up our coding playground, VS Code. Go to code.visualstudio.com and download Visual Studio Code for your system. Install it. It's super quick. Once it's open, let's add the Python extension. Click the extensions icon on the left. It looks like a little square with 4 boxes. Search for Python by Microsoft and click Install. This gives us awesome features like autocomplete and debugging for Python. Now, let's write our first code. Create a new file. I'll call mine hello.py and type print hello codepilots. Save it, then click the Run button in the top right corner of VS Code, or open a terminal in VS Code and type python hello.py. Boom! It prints hello codepilots to the screen. You just wrote your first Python code. How cool is that? That's it for episode 1, CodePilots. You've taken your first step into the world of Python, installed it, set up VS Code, and wrote your first line of code. In the next episode, we'll dive into variables and data types to start building real programs. If you love this, smash that like button, hit subscribe, and turn on the bell. We've got a long, amazing journey ahead. Share this with your coding friends, and I'll see you in episode 2. Keep soaring, CodePilots. Hello, CodePilots. Welcome back to Python from Zero to Hero, episode 2. Last time, we took off with a bang, got Python and VS Code set up, and wrote our first Hello CodePilots. Now, we're diving deeper into the wild west of coding with something called variables and data types. These are the building blocks of every program you'll ever write. Think of them as your trusty horses that carry your code across the plains. So saddle up, grab your keyboard, and let's learn how to tame them together. Hit that like button if you're ready, and let's ride. All right, let's talk variables. A variable's like a labeled bucket where you store stuff, numbers, words, anything you want to use later. In Python, you just pick a name, use the equal sign, and put your value in. Simple, right? Let's try it. Open VS Code and create a new file. I'll call mine variables.py. Type this. Age equals 25. Here, age is my variable and 25 is the value. To see it, add print age. Run it, boom, 25 pops up. You can change it too. Let's say age equals 30 and print again. See? Your bucket's got a new value. Variables can hold all sorts of things, and that's where data types come in. Data types are the kinds of stuff you can put in those buckets. Let's meet the main ones. First, we've got integers, whole numbers like 25 or -7. Type number equals 42 and print number. Next, floats, numbers with decimals like 3.14. Try pi equals 3.14 and print pi. Then strings, words or text, wrapped in quotes. Let's do name equals codepilot and print name. Lastly, booleans, true or false values, like is coding fun equals true and print is coding fun. Run each one. See how Python knows what type each is? You can also check with type function. Try print type age, and it'll say class int. Pretty neat, huh? Now let's mix things up a bit. Variables can do more than just sit there. Let's add some numbers. Type x equals 10, y equals 5, and sum equals x plus y. Print sum and you'll get 15. You can even combine strings. Try greeting equals hey plus name and print greeting. It'll say hey codepilot, but watch out, don't mix types unless you mean to. If you do result equals age plus name, you'll get an error because you can't add an int and a string. To fix it, convert with string, like result equals string, age plus name, and print result. Now it works. This is key for building cool programs. Codepilots. That's the roundup for episode 2, folks. You've learned how to wrangle variables and tame data types. Integers, floats, strings, and booleans. These are your tools to start coding like a pro. Next time, we'll gallop into conditionals and loops to make our code smarter. If you're loving this ride, smash that like button, subscribe, and ring the bell. We've got a long, epic journey ahead. Drop a comment if you're stuck, and share this with your coding crew. Keep soaring, code pilots. Yo, code pilots, welcome back to Python from Zero to Hero, Episode 3. We've already saddled up with Python basics and wrangled variables in our last ride. Now, we're hitting the trail of conditionals, those if-else statements that let your code make decisions like a sharp-eyed cowboy. We'll learn how to check conditions, take different paths, and even build a tiny game by the end. So grab your keyboard, hit that like button if you're ready, and let's ride into the sunset of coding. Let's start with the basics of conditionals. They're like forks in the trail where your code decides which way to go. Open VS Code and create a new file. I'll call mine conditionals.py. First, we'll use if to check a condition and else to handle the other case. We'll see if someone's old enough to vote based on their age. In the code, I'll add a comment to explain this concept before we write it. Type #conditionals with if-else. We use if to check a condition, like age equals 18. If true, we do one thing, like printing "you can vote." If false, the else block runs. And now the code. Age equals 20. If age equals 18, print "you can vote." Else, print "sorry, you can't vote yet." Run it. You'll see "you can vote" because 20 is greater than 18. Change age to 16. Run again. Now it's "sorry, you can't vote yet." That colon and indent after if tell Python what to do if the condition's true. Let's add more options with elif. That's else if for when you've got multiple paths to choose from. We'll check school grades based on a score. Before the code, let's add a comment to explain. Hashtag using elif for multiple conditions. When you have more than 2 outcomes, use elif to check additional conditions. Here, we'll assign grades based on a score. And now the code. Score is equal to 85. If score is equal to 90, print A, awesome job. Elif score is equal to 80. Print B, great work. Else, print keep studying. Run it. Since 85 is between 80 and 90, you'll get B, great work. Change score to 95. Run again. Now it's A, awesome job. You can stack as many elifs as you need, and else catches everything else. Now, let's combine conditions with and or to make smarter decisions. We'll check if someone's a teen. Then, if it's the weekend, here's the comment. Hashtag combining conditions with and or. Use and when both conditions must be true, like age between 13 and 19. Use or when either condition can be true, like Saturday or Sunday. And the code, age equals 15. If age is greater than 13 and age is greater than 19, print you're a teen. Else, print not a teen. Run it. You're a teen, 'cause 15 fits the range. Next, day equals Saturday. If day equals Saturday or day equals Sunday, print it's the weekend. Else, print back to work. Run it. It's the weekend. Change day to Monday. Run again. Back to work. These operators let you handle more complex decisions. Time for a mini project, a rock, paper, scissors game. We'll set up choices and decide the winner. Comment first. Hashtag mini project, rock, paper, scissors. We'll compare player and computer choices using if, elif, else. This game will decide the winner based on the classic rules. And the code. Player equals rock. Computer equals scissors. If player equals computer, print it's a tie. Elif player equals rock and computer equals scissors, print you win, rock crushes scissors. Elif player equals paper and computer equals rock, print you win, paper covers rock. Else, print you lose. Run it. You win, rock crushes scissors. Change player to paper or scissors and test it out. We'll expand this game later, but you're already rocking it. That's a wrap for episode 3, Code Pilots. You've learned how to steer your code with if-else statements, check multiple conditions, and even built a tiny game. Next time, we'll dive into loops to make your code repeat, like a trusty horse on a long trail. If you love this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you've got questions, and I'll see you in episode 4. Keep soaring, Code Pilots. Hello, Code Pilots. Welcome back to Python from Zero to Hero, episode 4. We've been riding the trail with variables and conditionals, and now it's time to loop the loop with, loops. These are the tools that make your code repeat tasks like a cowboy herding cattle. We'll cover for loops, while loops, and even break them up with some control tricks. So saddle up Hit that like button if you're ready, and let's get looping. Let's kick off with for loops. These let your code repeat over a sequence, like counting stars in the sky. Imagine we want to print numbers from 1 to 5. Here's the concept. For loops. These repeat a block of code for each item in a sequence, like a list or range of numbers. And now the code. For I in range 1 to 6, print I. Run it. You'll see 1, 2, 3, 4, 5. The range 1 to 6 gives us numbers from 1 up to, but not including 6. Let's try it with a list. Type fruits equals apple, banana, orange. Then for fruit in fruits, print fruit. Run it. Each fruit prints on a new line. This loop's like walking through a row of horses, checking each one. Now let's explore while loops. These keep going as long as a condition's true, like waiting for the sun to rise. Here's the idea. While loops. These repeat code while a condition holds true, like counting down until 0. And the code, count equals 5, while count greater than 0, print count. Count equals 1. Run it. It counts down 5, 4, 3, 2, 1. That count equals 1 decreases the number each time, or we'd loop forever. Watch out for that. Let's try a guessing game. Type guess equals 0. While guess isn't 5, guess equals int input, guess a number. Print, got it, 5. Run it. Keep guessing till you hit 5. This loop keeps asking until the condition's met. Sometimes you need to control loops. Enter break and continue. Here's the concept. Loop control with break and continue. Break stops the loop early, while continue skips to the next iteration. And the code. For I in range 1, 6. If I equals 3, break. Print I. Run it. It prints 1, 2, then stops at 3, 'cause break exits. Now, try for I in range 1, 6. If I equals 3, continue. Print I. Run it. 1, 2, 4, 5. 3's skipped, 'cause continue jumps over it. These are like reins to steer your looping horse. Let's wrap up with a mini project. A number printer with a twist. Here's the plan. Mini project, number printer with break. We'll print numbers, but stop when we hit a specific value. And the code, for I in range 1 to 11. If I equals 7, break. Print I. Run it 1 through 6 print, then it stops at 7. Now, add a continue twist. For I in range 1 to 11, if I mod 2 equals 0, continue, print I, run it. Prints only odd numbers, 1, 3, 5, 7, 9, 11, 3, 5, 7, 9, 'cause even ones are skipped. Play with these, change the range or condition to see what happens. That's a wrap for episode 4, Code Pilots. You've mastered for and while loops, learned to control them with break and continue, and built a fun number printer. Next time, we'll gallop into lists to organize your data like a pro. If you loved this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you're stuck, and I'll see you in episode 5. Keep soaring, Code Pilots. Yo, Code Pilots. Welcome back to Python from Zero to Hero, episode 5. We've been looping and deciding with conditionals, and now it's time to round up some data with lists. These are like your trusty saddlebags for carrying a bunch of items. We'll learn how to create them, access them, and even tweak them. So grab your hat, hit that like button if you're ready, and let's herd some data together. All right, let's talk lists. Think of them as a row of buckets where you can store multiple things, like numbers or words. Here's the scoop. Lists allow us to group related data together in an ordered sequence, and we can add or remove items as we go. Open VS Code, and let's create a new file. I'll call mine lists.py. Time to write some code. First up, my list equals 1, 2, 3, 4, 5. This is a list of numbers. Run it with print my list. You'll see 1, 2, 3, 4, 5. Now, let's try a mixed list. Mixed list equals apple 42 true. Print mixed list. It prints apple 42 true. Lists are flexible like that. Hold in different types all in one place. Next, let's grab stuff from our lists. Kind of like picking an item from your saddlebag. Here's the deal. We can access list items using their index, which starts at 0, to get specific values. Type fruits equals apple, banana, orange. Print fruits 0. Runs to apple because the first item's at index 0. Try print fruits 1. Gets banana. You can also change items, like fruits 1 equals grape. Print fruits. Now it's apple, grape, orange. Negative indices work too. Print fruits -1 gives orange, the last one. This is how you navigate and tweak your list. Let's add some action. Lists can grow and shrink like a herd on the move. Here's the lowdown. We can use methods like append to add items, remove to take them out, and more to manage our list. Type numbers equals 1, 2, 3, numbers append 4, print numbers. Now it's 1, 2, 3, 4. Add numbers, remove 2, print numbers. Drops 2, leaves 1, 3, 4. You can also use pop. Last equals numbers.pop. Print last. Gets 4 and print numbers. Shows 1, 3. These methods let you control your list like a pro cowboy. Time for a mini project. Let's build a shopping list manager. Here's the plan. We'll create a list, add items, and remove them based on user choice. Type shopping equals milk, bread. Shopping.append eggs. Print shopping shows milk, bread, eggs. Now, shopping.remove bread. Print shopping leaves milk, eggs. Let's add some flair. Shopping.insert 1 butter. Print shopping. Now it's milk, butter, eggs. Play with it. Add your own items and see how it updates. That's a wrap for episode 5, Code Pilots. You've learned how to wrangle lists, access and modify them, and built a handy shopping list. Next time, we'll trot into tuples and dictionaries to level up your data skills. If you loved this, smash that like button, subscribe, and ring the bell. We're riding strong. Drop a comment if you're stuck, and I'll see you in episode 6. Keep soaring, Code Pilots. Yo, Code Pilots. Welcome back to Python from Zero to Hero, episode 6. We've been riding the trail with variables, conditionals, loops, and lists, and now it's time to wrangle your data with tuples and dictionaries. These are like super-powered saddlebags for organizing info. We'll learn how to use them and build a mini contact book by the end. So, grab your hat, hit that like button if you're ready, and let's saddle up. Let's start with tuples. Think of them as a locked box of items you can't change. Open VS Code and create a file. I'll call mine Tuples.py. Here's the plan. Tuples let you store a sequence of items that stay fixed. Perfect for data you don't want to mess with. Type this code. First line makes a tuple called myTuple with numbers 1, 2, 3. My tuple equals 1, 2, 3. Run it with print my tuple. You'll see 1, 2, 3. Try accessing the first item with print my tuple 0. Gets 1, 'cause indexing starts at 0. Now, if you try to change it like my tuple 0 equals 5, you'll get an error. Tuples are immutable, meaning they can't be altered. Next up, dictionaries. These are like a treasure map where you store data with keys and values. Here's the idea. Dictionaries let you pair keys with values, like item names and their details. Type my dict equals item, laptop, price 500. Print my dict shows laptop, price 500. Access a value with print my dict item. Gets laptop. You can add a new pair like my dict quantity equals 10. Print my dict. Now it's item, laptop, price 500, quantity 10. Change a value with my dict, price equals 450. Print my dict, updates to 450. Dictionaries are flexible. Unlike tuples, let's combine them in a mini project, an inventory tracker. Here's the plan. We'll use a dictionary to store items, with names as keys and tuples of price and stock as values. Type inventory equals laptop 510, phone 315. Print inventory shows the dictionary. Access the phone's price with print inventory phone 0 gets 300. Add a new item like inventory tablet equals 205. Print inventory adds tablet. This mixes tuples stability with dictionaries flexibility. Time to wrap up with some tips. Tuples are great for fixed data, like coordinates, while dictionaries shine for dynamic stuff, like inventory lists. Avoid mixing them up. Don't try to change a tuple or use a dictionary where a tuple fits. Test your code and you're golden. This inventory tracker can grow, add more items, or track sales later. That's a wrap for episode 6, Code Pilots. You've mastered tuples and dictionaries and built a slick inventory tracker. Next time, we'll gallop into functions to level up your skills. If you loved this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you've got questions, and I'll see you in episode 7. Keep soaring, Code Pilots. Yo, Code Pilots. Welcome back to Python from Zero to Hero, episode 7. We've been riding the trail with variables, conditionals, loops, lists, tuples, and dictionaries, and now it's time to level up with functions. Functions are like your personal code shortcuts. They let you write something once and use it again and again. We'll learn what they are, how to build them, and even create a mini calculator to put into work. So grab your hat. Hit that like button if you're pumped, and let's get started. Let's start with the basics. What's a function? Think of it like a recipe. You write the steps once, then cook it whenever you want. Open VS Code and create a file. I'll call it functions.py. Look at this. Def say hello equals print hey there codepilot. This is a function definition where def starts it, say hello is the name, and the code inside does the job. To use it, call it with say hello. You'll see hey there codepilot. That's how you avoid typing the same thing over and over. Now, let's make it personal. Def say hello, name, print fa there. Call it with say hello, Mishi. Shows hey there, Mishi. This shows how parameters let you pass data into a function. Let's dive into more. Functions can give back results with return. Check this out. Def add numbers A, B return a plus b. This defines a function that adds two numbers. Call it with result equals add numbers 3, 4, and print f result. You get result 7. The return sends the answer back, so you can save or use it later, like in a game score. You can also handle more inputs. Def multiply numbers, x, y, z, return x times y times z. Call it with product equals multiply numbers 2, 3, 4, and print f product gets product 24. This makes functions perfect for repeated math or tasks. Now let's explore defaults and flexibility. Add a default value. Def greet user, name codepilot, print f hello name. Call it with greet user, shows hello codepilot, or greet user Jake, shows hello Jake. This means you can skip the input if you want. Functions can also return multiple things. Def get details, return 25, Bali. Call it with age city equals get details and print f age city gets age 25, city, Bali. This is great for packing related data together. Time for a mini project, a calculator. Let's build it step by step. Start with def add calc, num1, num2. Return num1 plus num2. Test it with sum result equals add calc 5, 3. And print f sum result shows sum 8. Now add choices. Def calc all num1, num2 operation. If operation equals plus, return num1 plus num2. Elif operation equals minus, num2. Elif operation equals star, return num1 times num2. Else, return oops, operation not recognized. Pick plus, minus, or star. Test with diff equals calc all 5, 3. And print f difference product prod. Gets difference 2, product 8. This shows how functions can handle multiple operations. Let's wrap up with tips. Keep functions small. Each should do one task, like add-in or greet-in. Use clear names like add calc instead of something vague. Avoid changing global variables inside unless you plan it. And test with big or negative numbers to catch bugs. This calculator can grow. Add division or a loop to keep asking for inputs. Practice, and you'll be writing reusable code like a pro. That's a wrap for Episode 7, Code Pilots. You've mastered functions and built a slick calculator. Next time, we'll ride into modules to organize your code. If you loved this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you've got questions, and I'll see you in Episode 8. Keep soaring, Code Pilots. Yo, Code Pilots, welcome back to Python from Zero to Hero, Episode 8. We've been riding through variables, conditionals, loops, lists, tuples, dictionaries, and functions, and now we're moving to modules. Modules are like your code organizers. They let you split your work into neat packages and reuse them anywhere. We'll learn what they are, how to make them, and even build a custom math tool to see them in action. So grab your hat, hit that like button if you're ready, and let's dive into this new adventure. Let's start with the big question. What are modules? Imagine your code is a big toolbox, and modules are the drawers where you keep your tools separate. In Python, a module is just a Python file with functions, variables, or classes you can reuse. Open VS Code and create two files, one called mymodule.py and another main.py. A module is like your code drawer, keeps functions and vars organized for reuse. Then type def say hi, print hi from my module. This is a function definition inside a module. Now, switch to main.py and import it with import my_module. Then, call my_module.sayHi. You'll see hi from my module. This shows how modules let you organize and access code from another file, keeping everything tidy. Let's dig deeper. How do you use modules? You can import specific parts. Back in my_module.py stores a number and a function to add two values. Add my variable equals 42 and def add nums ab, return a plus b. Save it. In main.py, import specific items from the module. Use from my module import add nums my variable. Now, call print add nums 53 gets 8 and print my variable gets 42. This way, you only grab what you need, save in memory. You can also use aliases with import my module as mm and call mm.sayHi. Same result. Modules are great for avoiding clutter and making your code reusable across projects. Now let's talk about built-in modules. Python comes with a bunch ready to use. One is the math module, perfect for calculations. In main.py, brings in Python's math tools for calculations. Type import math and try print math squart 16. You'll get 4.0, the square root. Or use print math.py. Gives you 3.14159, a constant. These built-in modules save you from writing complex math yourself. You can also import specifics, like from math import sin, cos, with import-specific math functions like sine and cosine. Test print sin math pi over 2 gets about 1.0. This shows how modules extend Python's power with pre-made tools. Time for a mini project, a custom math tool. Let's create a module for our own calculations. In my_module.py, a function to square a number. Add def square num, return num times num. A function to cube a number. Add def cube num, return num times num times num. A constant value to use. Add my constant equals 10. A function to raise a number to a power. Add def power, base, expand. Return base times expand. Save it. In main.py, use our custom math functions and constant. Use from my module, import square, cube, my constant, power. Test with print square 4, gets 16. Print cube 3, gets 27. Print my constant, gets 10. And print power 23, gets 8. This custom module lets you build and reuse your own math functions, making your code super flexible. Let's wrap up with some key points. Keep modules focused. Each should handle one area, like math or greetings. Name them clearly, like my module or math tools. Watch out for name clashes. If two modules have the same function, use aliases or full paths, like my_module.addNums. Test your imports to ensure everything works. This math tool can grow. Add more functions like division or logs, or even share it with friends. Practice, and you'll be organizing code like a pro. That's a wrap for episode 8, Code Pilots. You've mastered modules and built a slick math tool. Next time, we'll gallop into file handling to save and load data. If you loved this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you've got questions, and I'll see you in episode 9. Keep soaring, Code Pilots. Yo, Code Pilots! Welcome back to Python from Zero to Hero, episode 9. We've journeyed through variables, conditionals, loops, lists, tuples, dictionaries, functions and modules, and now we're tackling file handling. File handling is like giving your code a memory. It lets you save data to files and load it back whenever you want. We'll learn the basics, explore different ways to work with files, and build a note-saving project to put it all together. So grab your hat, hit that like button if you're excited, and let's get rolling. Let's start with the basics. What is file handling? It's how Python lets you interact with files on your computer, like saving a grocery list or reading a story. Open VS Code and create a file called main.py. First, handles opening and closing a file safely. Type with open notes text w as file.write hello codepilot. This opens a file named notes.txt in write mode. W writes a line and closes it automatically. Now, read it back with handles reading content from a file. Use with open notes.txt r as file. Content equals file.read and print content. You'll see hello codepilot. The with statement ensures the file closes properly, keeping your program safe and clean. Let's dive into file modes. There are different ways to open files. Write mode W creates a new file or overwrites it like before. Try it again with open notes text to Q as file and read it. Now it's new note here. Append mode A adds to the end instead. Use appends text without overriding. With open notes text as file write another line. The end starts a new line. Read it again and you'll see new note here, another line. Read mode R is for viewing only, which we did earlier. These modes give you control over how you handle files. Now, let's explore reading files in detail. You can read line by line. Use reads file line by line. With open notes.txt as file for line and file, print line strip. Strip removes extra spaces. If you added those two lines, it'll print each one separately. You can also read all lines into a list with reads all lines into a list. Use with open notes.txt as file, lines equals file.readLines, and print lines. Gets a list like new note here and another line. This is handy for processing file data step by step. Time for a mini project, a note-saving tool. Let's build it. Create main.py and add saves a new note to a file. With open notes.txt a as file, note equals input enter a note. File write full fn note. Run it. Type buy milk and check notes.txt. It's added. Now, add reads and displays all notes. With open notes.txt r as file, print your notes. For line and file, print line strip. Run it again, and it shows all notes. To clear the file, add clears the file content. With open notes.txt w as file write empty, this wipes it. This tool lets you save, view, and clear notes, making file handling practical. Let's wrap up with some tips. Always use with to avoid leaving files open. Check if a file exists before writing to prevent errors. Use import os and os.path.exists notes.txt. Don't write huge data in one go. Use append mode for big files. Test with different inputs like empty notes to catch issues. This note tool can grow, add dates, categories, or save to different files. Practice, and you'll be handling files like a pro. That's a wrap for episode 9, Code Pilots. You've mastered file handling and built a slick note-saving tool. Next time, We'll ride into error handling to make your code bulletproof. If you loved this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you've got questions, and I'll see you in episode 10. Keep soaring, Code Pilots. Yo, Code Pilots. Welcome back to Python from Zero to Hero, episode 10. We've soared through variables, conditionals, loops, lists, tuples, dictionaries, functions, modules, and file handling. And now we're tackling error handling. Error handling is like your code safety net. It catches mistakes before they crash everything. We'll learn how to spot and fix errors and build a tough calculator to test it out. So grab your hat, hit that like button if you're ready, and let's dive in. Let's start with the basics. What's error handling? It's your way to deal with problems like dividing by zero or typing the wrong data. Open VS Code and create a file called main.py. Handles errors to keep code running smoothly. Add try, result is 10 divided by 0. Accept zero division error. Print, can't divide by 0. This tries the division, but if it fails, it prints a message instead of crashing. Run it, and you'll see can't divide by 0. The try block tests the code, and accept catches the error, keeping your program alive and user-friendly. Let's dig deeper. How do you handle different errors? Errors have specific types, like value error for bad input. Try catches invalid input errors. With try, number equals int, input enter a number. Print number. Accept value error. Print, that's not a number. If you type ABC, it catches the error and says that's not a number. You can catch multiple errors with multiple accept blocks. Try handles division and input errors together. Add try, num equals int, input, enter a number. Result equals 10 divided by num. Accept value error. Print, not a number. Accept zero division error. Print, can't divide by 0. This covers both cases neatly. Now let's use else and finally for more control. The else runs if no error happens. Try runs code if no errors occur. With try, num equals int, input, enter a number. Result equals 10 divided by num. Accept value error. Accept zero division error. Print, can't divide by 0. Else, print result. If you enter 2, it shows result 5.0. The finally block always runs, even with errors. Adds cleanup code that always executes. Add finally, print, done calculating. It prints after every try, no matter what. This makes your code more robust. Time for a mini project, a robust calculator. Let's build it. Create main.py and add builds a safe calculator with error handling. With while true, try. num1 equals float input, enter first number. num2 equals float input, enter second number. op equals input, enter operation, plus, minus, or y. If op equals divide by plus, result equals num1 divide by num2, equals num1 times num2, equals num1 plus num2, equals num1 plus num2, equals num1 minus num2. Else, raise value error, invalid operation. Accept value error as e, print, error. Accept zero division error, print, error. Can't divide by 0. Else, print, result, result. Finally, print, ready for next calculation. Test it with 4.2 and divide by 0. Gets result 2.0. Try ABC, or it handles errors gracefully. This loop keeps it running. Let's wrap up with some tips. Use specific accept clauses to catch exact errors. not just a general one. Add raise to throw custom errors if needed. Test with edge cases like negative numbers or empty inputs. This calculator can grow. Add more operations or save results to a file. Practice, and you'll be handling errors like a pro, making your code rock solid. That's a wrap for episode 10, Code Pilots. You've mastered error handling and built a tough calculator. Next time, we'll explore object-oriented programming to level up your skills. If you loved this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you've got questions, and I'll see you in episode 11. Keep soaring, Code Pilots. Yo, Code Pilots. Welcome back to Python from Zero to Hero, episode 11. We've mastered variables, conditionals, loops, lists, tuples, dictionaries, functions, modules, file handling, and error handling, and now it's time for our first big project, a number guessing game. This game will test your skills with loops, conditionals, and random numbers. We'll build it step by step, add features, and make it fun. So grab your hat, hit that like button if you're ready, and let's dive into coding. Let's start with the idea. The game picks a random number between 1 and 100, and you guess it. It tells you if you're too high or too low. We begin by bringing in a tool to generate that number. Think of it as a magic box for random choices. Then, we set up a secret number that the game keeps hidden, using that tool to pick something between 1 and 100. We also start a counter to track how many guesses you make. The heart of the game is a loop that keeps going until you win, asking you to enter a number each time. Inside, it checks if your guess matches the secret number, and if it does, it celebrates your win and stops. If not, it lets you know if you're too low or too high, giving you a hint to try again. Give it a go by guessing a few times to feel how it guides you toward the answer. Now let's add a challenge. Let's limit it to 10 guesses. We start by setting a maximum number of tries to keep things interesting. The loop changes, so it only runs as long as you're under that limit, making each guess count. Every time you guess, the counter goes up, tracking your attempts. The win check stays the same, stopping the game when you get it right. But now, if you hit the maximum tries, it tells you the game's over and reveals the secret number. Try guessing wrong 10 times to see how it wraps up, adding that extra layer of excitement. Let's make it smarter by tracking the range of your guesses. We set a starting low point at 1 and a high point at 100 to frame the game. When you enter a guess, the prompt now shows that range to help you focus. If your guess is too low, the game updates the lowest possible number to just above your guess, narrowing the field. If it's too high, it adjusts the highest number to just below your guess, closing in on the target. This makes each try more strategic. Test it out by guessing 50, then 25 when it says too low, and 75 when it says too high, watching how the range tightens up. Let's keep the fun going by making it replayable. We set up a condition to ask if you want to play again at the start. A bigger loop wraps the whole game, running as long as you say yes, giving you a fresh start each time. Inside, we reset the secret number to a new random pick, clear the guess counter, and refresh the limits and range. After you win or lose, it asks if you want another round. Try winning, then type yes to play again, and enjoy the endless fun this adds to the game. Let's reward your skill with a score system. When you guess correctly, the game calculates a score based on how fast you got it, starting with a big number and subtracting points for each guess. If that score dips below 0, it caps at 0 to keep it fair. Then, it shares your score with a win message to celebrate. Give it a shot with 5 guesses to see a decent score, and try 10 guesses to see it hit 0, showing how speed pays off. Let's save your best moment by storing the high score in a file. We bring in a tool to check if a file exists, ensuring we can read or create it. If there's an old high score, it loads that number. If not, it starts at 0. After calculating your new score, it compares it to the high score. If you beat it, the game saves your new record to the file and announces your triumph. Otherwise, it reminds you of the current high. Test this by setting a high score, beating it, and checking the file to see your name in lights. Let's give you a helping hand with a hint system. We set a limit of 3 hints to keep it balanced. Inside the guessing loop, it asks if you want a hint before each try. If you say yes, it figures out the midpoint of the current range and suggests a number around there, then reduces your hint count. This gives you a clue without giving it all away. Try saying yes a few times to use your hints and see how they guide you closer. Let's spice it up with different difficulty levels. At the beginning, it asks you to pick a level, letting you choose how hard you want it. Depending on your choice, it sets a different number of guesses and a range for the secret number. Easy with more tries and a smaller range, medium as a balance, and hard with fewer tries and a bigger range. The game then picks a new secret number based on that level. Test each level to feel the shift in challenge, from easy to hard. Let's add some pressure with a timer. We bring in a time tool to track how long you take. The guessing loop now checks not just your guesses, but also if you're within a 60-second limit. If time runs out, it stops the game and reveals the number. Try guessing quickly within the time, or let it expire to see the cutoff in action, adding that rush to beat the clock. Let's make it welcoming with an intro screen. The game starts by printing a title to set the mood, then shows the range you're working with. It also displays how many guesses and seconds you get and mentions the hint option to prep you. Run it to see this friendly start, making the game feel more like a polished experience. Let's make sure it's solid by testing and fixing. Try entering something like 0 or letters to see if it handles bad input gracefully. Check what happens after the time runs out or when you use all your hints. We add a safety net to catch invalid numbers and keep the game going. Test these edge cases to ensure everything runs smoothly without crashing. Let's wrap up with some tips. Test every level and feature to catch any quirks. Save your high scores regularly to avoid losing them. You could even add sounds or graphics later with extra tools. This game has room to grow. Think multiplayer modes or leaderboards. Keep practicing, and you'll be on your way to becoming a game development star. That's a wrap for episode 11, Code Pilots. You've built an epic number guessing game. Next time, we'll create a to-do list manager. If you loved this, smash that like button, subscribe, and ring the bell. We're just getting started. Drop a comment if you've got questions, and I'll see you in episode 12. Keep soaring, Code Pilots. Yo, Code Pilots, we've just soared through the first part of Python from 0 to hero. 1-hour journey across 11 amazing episodes. This summary will recap your wins. Practice projects, read books, or take courses. Set goals, like making a game or analyzing data, and track your progress. The Python community is huge, so lean on it to learn and share. That's a wrap for part 1. You've mastered the basics and built something amazing. Like this video, comment with your thoughts, and keep coding your own story. See you in the Python skies.